In our project, we built an image style transfer. It is always a challenging task to render the semantic content of an image in different styles, because of the lack of features which explicitly representing the image semantic formation or separating image content from style. The neural style algorithm is a new method to solve this problem, which synthesizes a pastiche by separating and combining the content of one image with the style of another image using convolutional neural networks. Our work is a TensorFlow implementation of several techniques. We established the model on the basis of VGG network, the pre-trained network, which has trained to perform object recognition and localization. Particularly speaking, we use the version of the 16 convolutional and 5 polling layers of the 19-layer VGG network. For image synthesis, we replace the maximum polling with average polling, which have better results. In addition, we also add normalization operation to the network by scaling weights, such that the mean activation of each convolutional filter of images and positions is equal to 1. Deep image representations includes content representation and style representation. Generally, each layer in the network defines a nonlinear filter bank whose complexity increases with the position of the layer in the network. Hence, a given input image is encoded in each layer of the convolutional neural network by the filter responses to that image. A layer with Ni distinct filters has Ni feature maps for each size Mi, where Mi is the height times the width of the feature map. One can perform gradient descent on a white noise image to find another image that matches the feature responses of the original image. Assuming P hat and X hat are the original image and the image that is generated, and PL and FL are their respective filter representation in layer L. We can define the squared error loss between the two feature representations, and also the derivative of this loss with respect to the activations in layer L, from which the gradient with respect to the image X hat can be computed using standard error backpropagation. Thus, we can change the initially random image X hat until it generates the same response in a certain layer of the convolutional neural network as the original image P hat. Then, we implement this calculation with function below. We use a feature space design to capture texture information. This space can be built on top of the filter responses in any layer of the network, consisting of the correlation between the different filter responses. These feature correlations are given by gram matrix, where it is the inner product between the vectorized feature maps. Using gradient descent from a white noise image to minimize the mean square distance between the entries of the gram matrix from the original image and the gram matrix of the image to be generated. Let A hat and X hat be the original image and the image that is generated, and AL and GL are their respective style representation. Then we get the contribution of layer to the total loss and the total style loss. The derivative of EL with respect to the activations in layer L can be computed analytically. The gradient of EL with respect to the pixel value X hat can be readily computed using standard error backpropagation. Then we implement this calculation with function below. To transfer the style of an artwork A hat onto a photograph P hat, we synthesize a new image that simultaneously matches the content representation of P hat and the style representation of A hat. Hence, we jointly minimize the distance of the feature representation of a white noise image from the content representation of the photograph in one layer, and the style representation of the photograph in one layer, and the style representation of the painting defined on a number of layers of the convolutional neural network. We got the loss function. To extract image information on comparable scales, we always resize the style image to the same size as the content image before computing its feature representations. Below image is the detailed process. The fundamental codes include two core parts, VGGNet and the specific rendering. Here is the most interesting rendering part, and also the loss we got in the training process. Here is our result. We transfer a daily life picture into three famous paintings: the Starry Night, Shipwreck, and also the Scream. We also applied a cartoon style into a girl image, and we got a very interesting result. That's all. Thank you for watching. Bye bye.